Okay, in today's session, just started here. I'm going to go over a little bit over assignment 3. It might be a pretty quick session here, but I'll leave it up here to see if anybody joins live, wants to ask questions. So as usual, I mean, I consider these times for that I scheduled for the class sessions for this online class as part of contact, so part of my ability to contact me, so if you're just watching these videos, come join us live if you have questions, if you can. So that's one way. If you need to get with me to ask a question about something, but if you can't come during these scheduled times, just send me emails and we can set up a schedule for a Zoom meeting or whatever if you need it. So, I mean, as usual, I thought I'd talk a little bit about assignment 3, look at the task, make certain everybody knows kind of what's going on that. Let me go ahead and see if I can share the right screen this time. So, all right, so I've already started up my Vagrant dev box, and I've already connected to it, but I haven't accepted the assignment yet. So let's go ahead and kind of just, as usual, kind of remind people how to do that kind of stuff. Let's see if there's any kind of reminders about stuff. I mean, assignment 2, I did return back evaluations on that. So you should check your assignment 2 repositories to see what I said about those. Yeah, so this week we're talking about pointers and dynamic memory management. So the assignment for this week, you have to do a little bit with dynamically allocating an array and dynamically managing some memory. So this kind of solves the basic issue. I left it hanging on assignment 2 was that we actually, the set that we created, we did what was known as statically allocating the array. So we statically allocated an array that was a size 100 inside of our set for assignment 2. So that actually gave a limit, an upper limit on the number of items that we could have in our set, right? So if you wanted to have more than that, you either had to up that limit, but no matter how big you made that limit, there would always be a hard-coded limit if you statically allocate your array. And we didn't do any error checking, but to be safe, we really should have had some error checking in there on like the add item, and also on the set, the operator union intersect were both using add, the union was using add. So if we would have put the error checking in the add, it should have worked for it. But we really should have a check in there that if you're trying to add an item and there's already, the set is already at 100 or already at capacity, that you get an error message instead of it blowing past the end of the array of memory, right? So we would like to do something about that. So we would like to have a flexible container like a set, or I think this week we're going to be working on a list for our assignment here that doesn't have an upper limit. Or, I mean, there is always a limit. The limit is going to be the amount of actual physical computer memory you have. So, you wouldn't be able to store more stuff than you have in your physical computer memory. But that's much bigger than 100 or 1,000 or a million. So if you have typically 4 gigabytes of memory, typically something like a float or an int takes up 4 bytes, which is 32 bits. So that would mean that you could have, in 4 gigabytes of memory, you could have a gigabyte of data in one set or one array if you could dynamically use all that memory. I mean, you can't use really all of that because some of the memory has to be used by the operating system and stuff, but you get the idea. So that's kind of what dynamic memory allocation allows you to do is instead of having a hard-coded upper limit, we want to be able to dynamically grow our container, our size, if we need to. So let's accept the assignment. Oh, I didn't mean to do that. Need to accept it here where I'm logged in as my student account here. And there we go. So we should have a repository as usual. Make certain you follow the checklist. And once you get in here, and I did, while I'm thinking about it, I did want to show again. I mean, people. I mean, I can understand, but people are still having problems getting the code style checker and runner formatter isn't running for everybody still. So let me show that again. I've shown it before, but to make certain that you've got the class code style checker formatter running in your repository. So so we accepted the assignment. That's always step one. We've got everything set up so we can clone the repository. Let's clone. Make certain that you clone the SSH URL. So I'll copy that. Go over to the source control, we'll do clone repository, paste the URL in there. And we'll have it create the repository in the sync assignments. So I have my assignment 3 there. And we'll go ahead and open that up. And then once you clone your repository, make certain that you do the configuration steps. So if you don't do this, you won't have the code style checker, and there'll be other things that won't be working. So you should go to the menu and open a new terminal. If you have your repository open, it should open you in the directory that you need to be in to do the configuration. So one thing you'll see, if you don't have your project configured, you'll see that the IntelliSense is not finding stuff. So you'll get messages from your IntelliSense, because until you run configure, it doesn't create the .vs Code configuration in order to specify places to look for include files other than the standard locations. So that's /configure. When you do that, you should see after you do that you've got a .vs Code here with some settings files, task settings and things. And you should see that you have the CLang format. This is the thing that's used by the code style formatter checker. This defines all of our class styles. So how to handle opening, closing curly braces, where to put spaces around operators, what to use for indentation, and all kinds of other stuff that I consider the class style format, right? I've mentioned this before. I mean, this is more, people think of this as kind of trivial, but this is more than just a look, visual kind of thing, because when you're using repository source control like GitHub or a Git repository, you really want to have a common style that gets enforced by a checker like this, because if you have just small changes in spaces and things, especially if you're working with multiple people, but even if it's just yourself, you might be inconsistent. Sometimes use spaces and sometimes not. You'll end up getting more conflicts when you push changes to your repository than you would otherwise if you're maintaining a common style. Okay, so there's an actual practical reason for making certain your code formatter is working beyond just me being annoyed that you visually don't have your indentation correct and aren't using space around things. So you should be able to check this real quickly, that your code style checker is running. It should be working after you do that .configure and you have the CLang format. So a real quick check. I mean, if you put in like a if x equals 5, don't put any spaces in these. Something like that. All right. So again, normally, curly braces should be on a line of their own. There should be a space after keywords like if. There should be spaces around binary operators like equals and so on. So again, this is all stuff that's done by the style checker. And if you do that and you do a save, so it's supposed to be running the style checker whenever you do a file save, a save file. So if you do a save, it should reformat like that. So here it reformat, put the space in there, put the space around the binary operators, put the opening curly brace on a line of its own, indented correctly for the code block level, same with the closing curly brace and so on, right? So, I mean, that's a quick way to check. Just put in some obviously unformatted code, and this should be, enforcing indentation in general, right? So if I'm indented really strangely, you know, again, it should fix all of that indentation and formatting if you do it, if you have the format on save. So sometimes the format on save, the keyboard thing isn't working, but you do have your IntelliSense, or sorry, you do have the CLang code formatter working. So you can always format this by hand by like right clicking and format document. So that's like Control Shift I guess. So that's another way to just to know. So if it doesn't seem to be formatted on save, you can at least check if the files, the CLang format file seems to be present or not by doing a right click or doing a Control Shift I to format your document. All right. So yeah, so so often these test cases are not quite formatted correctly. So these are indented incorrectly, and the indentation inside the block here is incorrect. So when you uncomment these and you save, it should reformat the indentation for like the test case, for example. All right, so let's look at the assignment. I'm going to go back to the readme. Let's see if I finished all these. We configured. So then, yeah, I mean, always another thing. If you don't do the configuration, you won't have the keyboard shortcut. So without the configuration, you ought to be able to do like a make from the command line, but you won't be able to do your keyboard shortcuts. So better comment that back up here. I should be able to do Control Shift 1 to do a clean, Control Shift 2 to invoke the make all. And again, that stuff, if your configuration is set correctly, you should be able to do the make by hand from a terminal, or use Control Shift 1, 2, and 3 to invoke clean, build, and make the tests, run the test from inside of the editor. So, and I guess we can go ahead and create our task 1 here, our issue 1. All right, so there, I think we've completed all the preliminaries, all of our checklist to get started. So, oh yeah, in this assignment, we're creating another class called LargeInteger. So this isn't a container this time. This is going to be a class to represent like an integer data type. So the normal integer that you have, so the basic int type is a 32-bit integer. So that means that there's a limit on the if you have 32 bits, you can only represent values up to 2 to the power of 32, which is actually 4 billion. And if you want to have a signed integer, you have to use one of the bits to indicate whether it's a negative or a positive integer. So in that case, one of the bits, you only have 2 to the 31, which is 2 billion. So this is basically 2 to the power of 31 minus 1, I think. So that's like the largest, and you can represent like negative of that using a signed integer. All right, but that's an upper limit. So sometimes if you're doing scientific calculations, you want to be able to represent integers even bigger than that, even bigger than 2 billion or 4 billion if you want to use an unsigned. So you could use like a 64-bit integer. So and in fact, I mean, that kind of really solves the problem for all but kind of the most extreme cases of large integers that you need. But another thing, so lots of high-level languages define a arbitrarily large integer type. So to do this, you have to represent an integer in a different way. You do it as a fixed set of bits. You have to keep an array of values. And in this case, we want to allow that array of values to dynamically shrink and grow, right? So if I do an operation on my large integer and I only have an array that can hold 10 digits right now, but the new result needs to be 15 digits long, I can grow my array to add 5 more digits and represent the extra digits. Okay, so that's in a nutshell kind of what we're doing with this large integer, and you know, we're doing this to practice doing dynamic memory allocation. So. And incidentally, you know, pointers. So in order to dynamically allocate memory, you have to be comfortable with using pointers and dereferencing pointers and things like that. So the first task is to implement a toString. So I should have probably gone back and been consistent and called this str like we did on the previous assignment. So that's become more standard. Just use str in the C++ language if you want to get a string representation of an object. But anyway, so just call it toString like we say here. So look at the representation of this. So this should make sense. So if we create, so again, we're using a class here, a large integer class. So we're adding a user-defined type called large integer. So if you look in LargeInteger.hpp, we define a class called large integer. It has a constructor and a destructor, and you're going to be adding the member functions for it, for this class here. So if you construct a large integer with a regular integer, and then if you ask for the toString, the string representation, you should get what you expect. So if I construct it with a 1, 2, 3, 4, 5, and I get toString, I should get a string back that has 1, 2, 3, 4, 5, because that's the value in my large integer, right? And this value is actually this value is a bit bigger than you can actually hold in a regular, I'm sorry. So yeah, we have to actually input a regular integer here. So there's no possible to initialize using this initializer with anything other than from, you know, bigger than can be held in a 32-bit integer. So this still fits in a regular integer. But anyway, so if we initialize it with these values, we expect a string back for this here. So what I wanted to say, this is just discussed, but you have to understand kind of the format that's being used here. So let's look at the constructor and how it works for the large integer here. Before I do that, so basically what we're doing is we keep 2 member variables. You don't have to do anything with the ID in this class, in this assignment, but we keep an array of digits and a number of digits. Okay, so notice, I mean, this might not look the way that you're normally used to thinking of an array. So if I wanted to create the array statically, I would declare it like that, to create an array of integers, of 100 integers here, right? But we're going to allocate it dynamically, which you should have learned about by going over the readings and my videos for the week here. So we haven't actually allocated it yet, but when we call the new method, we're going to allocate a block of however many integers that we need, and the new returns a pointer to that block of integers, okay? So we're going to just assign that pointer into this digit, but after you do that, you can use this like you would normally use an array, okay? So there's a pointer to the beginning of a block of values works the same way as an array in C, okay? So again, we discussed that a little bit in our materials for this week, right? So really an array, a regular array in C is just a pointer to the base address of that block of memory that's being used by that array, right? So, and we can tell how big the array is. So we're going to keep how many digits we have or how big the digit array is in the num digits here. Right? And you know, an example will make this clearer than maybe discussing this. So you look at the constructor, the one that takes an integer value. So we do some manipulations here. You probably don't have to understand this, but basically the result of this calculation is if I give an integer value that has the value 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 has 5 digits in it. So this little calculation here figures out how many digits are in this integer by taking the log of this and adding 1, right? So 1, 2, 3, 4, 5 is going to end up with that we need 5 digits. And then here we dynamically allocate an array of integers. So this is the syntax for using new. If I wanted just a single integer, like we talked about in our materials for this week, I could just do new int. That would get me a single integer, right? Which wouldn't be too useful. So I mean, is much more. We pretty much, whenever we're doing dynamic memory allocation, we dynamically allocate a block or an array of values like this. Or we dynamically allocate an instance of a class is the other kind of normal way that we use dynamic allocation. So anyway, so like if num digits is 5, this will dynamically allocate an array of exactly enough memory to hold 5 integers, right? And again, this returns a pointer. So we save that pointer in digit. But notice that after we have that, I mean, we can just use digit then as an array like you should be used to at this point, right? So ever after that, as long as we don't access a value, beyond the number of digits that we dynamically allocated, it's so if we allocated 5 digits, it's safe to initialize or access this array from the values from index 0 to 4. So an array of size 5 has indexes 0, 1, 2, 3, and 4, right? But another thing to understand in this is, so this basically then by using the mod and using a loop here, gets the actual digits out of the regular integer and puts them into the array here, all right? So, but we put the least significant digit at index 0, and then the most significant digit goes at the highest index. Okay, so like an integer. Values 1, 2, 3, 4, 5 is going to end up with the 5 is going to be at index 0. The 4 at index 1, 3 at index 2, and then the most significant digit is at the highest index 5 for the number of digits. Right? So why do we do that? Because this is the, so you got to know how to represent numbers in decimal, right? So this is the 10 to the power of 0. So these are all powers of 10. 10 to the power of 0 is our least significant digit. 10 to the power of 1. So we got 40. So 4 times 10 to the power of 1 or 40 is in the tens digit. 3 times 10 squared or 300s in the hundreds digit, and so on, right? So the index in the digit array also incidentally allows us to know what the power of 10 is for our large integer. So this is our 0th power digit, our first power, our tens digit, our second power, our hundreds digit, and our thousands digits, and our 10,000 digit, and so on. All right. So if you understand that, then so you should see that if to implement the toString method, and maybe I'll give you, like usual, the I keep hitting the wrong thing there. So the function signature for the toString takes nothing as input. It should be a constant member function, and it should return a string. And you should use an OString stream, like I asked people to use on the previous assignment to implement your toString here. So it'll look pretty much like the string that we used last time. the STR method that we used last time. So as usual, when I'm adding in the stub here, this is a member of our large integer class. So this is a member function. So we have to specify that it's a member of large integer, but otherwise it had the same signature as our as our declaration in the header file for this member function. So it's a constant member function that returns a string. Doesn't take any values as input. And I can start with a stub function like return 0 to get it to compile. That ought to pass the first test, but of course it won't pass the other test. So yeah, so it's not passing this test here. So now at this point, the way this constructor worked, we should have, like I said, we should have a 5 at index 0 of the digit and a 4 at index 1 and so on, right? So that basically means so if you want to end up with a result of 1, 2, 3, 4, 5, which is the correct result for the second test, remember the 1 is at index 4, right? So I mean, there's multiple ways to approach this. I think that I probably described that probably the easiest is just to iterate backwards through the array. So start at index 4, which is going to be number of digits minus 1. So number of digits should be 5. Because we've got 5 digits, which means that the largest index should be at num digits minus 1, which is 4. So if you iterate backwards from 4, 3, 2, 1, 0, and then stream those out to a string stream and return that, that should give you your implementation for the toString there, right? And that should work generally no matter how many digits you have. So you start at, whatever that ends up being, the 11th digit or the 12th digit, and go backwards to the 0th digit. So, all right, so yeah, so it should be a member of large integer. It should be a constant member function. Oh yeah, and I even gave you the prototype for that first one to get you started, same as we just showed there. So, all right, task 2 is to implement a constructor. So I didn't have you implement. I gave you a constructor for the previous assignment. Here's your first task where you have to actually implement a constructor. All right, so this constructor is going to take an array of integers, and you're just going to use that to initialize the large integer. So so here's an example of what we mean by that. So if we construct it, a large integer where we pass in an array, so this is an array of integers. The size of the array is 10, so there's 10 digits in here. So this constructor takes 2 parameters. It takes the number of digits and then an array of integers, which has the actual digits, those number of digits. So really all you have to do is dynamically allocate the digits array and then copy the values from this array that's passed into the digits array, but copy them in the record. Oh, but this array should be passed in the way that we expect for our digits to be formatted. So basically the least significant digit will be first. So the value that should go into index 0 will be at the 0th index of the array. And then the value at index 1 will be at index 1 of the array, and so on. So when you initialize an array like this value goes at index 0. So that's our 1's digit. This value goes at index 1. That's our 10's digit. and so on up to whatever this is, our 10 to the power 10 digit or whatever, right? So I mean, so you can have multiple constructors. We already had two constructors for this class. We had a default constructor and a standard constructor that takes a regular integer and uses that to initialize the large integer, right? So for this one, just as an example, right? We're passing in two parameters. We're passing in the number of digits. I don't really like new, so I'll call that the init initial number of digits, and then the init digits, the actual digits, right? We're passing in the number of digits and the array of digits here. This is like an array-based constructor. And yeah, I just added the constructor from the array prototype right there. So I'll remove that meta comment. All right. So constructors, as we talked about last week a little bit, are kind of special for a class. So they're called, right, whenever you create a new instance of the class. So like here, we're declaring an instance of a large integer class called li1. And you know, if we don't specify any parameters, the default constructor would get called. But depending, you know, based on the signature of how you construct the item, it knows which constructor to call. Or if it can't find a constructor that matches that signature, you'll get an error compilation trying to compile the program. But yeah, in this case, we need to add a constructor that takes an integer, an array of integers, so we can construct from that array of digits here. So there's a function prototype for the array-based constructor up here. So, you know, if you look at the previous constructor, the two constructors that we have, I mean, you do have to specify that it's a member of the large integer. So, so the name of the function should be the same for a constructor, class name. So what this syntax means is it's a member of the large integer class, and then the name is large integer. So, and since it's the same as the name of the class, that means it's a special one, it's a constructor, right? And constructors don't have a return type. So I mean, all functions in C should have a return value, return type, except constructors and destructors are special. They don't have, they don't really return anything explicitly like member functions, right? But you know, constructors can have parameters as input, like we had for this one, like you have to have for this one. All right. So anyway, I'm going to stop giving you code now, but you basically have to dynamically allocate an array of digits. Although in this case, you're already told the number of digits. That's the first parameter. So you have to allocate an array of digits of the size that's specified for this constructor. And then you're going to have a loop that copies the values. Sorry to keep scrolling back and forth, but a loop that copies the values from the init digits into the large integers array of digits. Right. So you have a loop that's similar to this, but it should be simpler. That's all stuff I added there, because you just simply have to copy. Instead of calculating what the digit is to put into your digit array, you have to copy the corresponding value from what I call init digits into your digits array inside of a loop. All right. So that was task 2. Going to add a constructor. And then in this assignment, we got like 5 tasks, no, 6 tasks again. So task 3 is to implement a max digits member function. So an example of that will be easier than trying to describe it. So here's the unit test for task 3. For task 3, and further on, there is, again, a test fixture. I think we had that in the previous assignment as well. So I should uncomment that before you, when you're ready to uncomment and work on task 3. So max digits, so here we're using these large integers that we define in this, what's called a test fixture. So for example, large integer 1 just uses a default constructor. So it initially has 1 digit with a value of 0. That's what the default constructor does. And large integer 2 has 1 digit, but with a value of 5. Okay, so this uses the other constructor that you pass in an integer. So again, both of these have 1 digit, all right? So the max digits between two things that have equal number of digits should just be whichever, it should be 1, because they both have 1 digit, okay? So like 3 and 4, so large integer 3 has 5 digits, and large integer 4 has 5 digits. So again, it should be 5 in that case. Let's find one that's not equal here. So 5 and 6. 5 has 5 digits, but large integer 6 has 17 digits. So if you ask the maximum number of digits, max is just the maximum between those two. It should be 17 in this case, right? Between 5 and 6. So that's all max digits does. So to implement that, you just have to compare the number of digits to this item to the number of digits of the other large integer. Okay. Oh, I know. So we're passing in. So we did this. We had to do this for the intersection and the union in the previous assignment. We're passing in an item of large integer type again for the task 3 here. So large integer should be passed in as a constant reference parameter. All right. So and it should be a constant member function as well. So max digit doesn't modify either of the large integers that are used in the comparison. So it's a constant member function. It should be passed in as a constant reference parameter. But yeah, so you can just compare the number of digits in this item to the number of digits in the other large integer that's passed in as a parameter here to figure out the max digit. Digit at position then is kind of like doing an index into the large integer. So so let's get a more interesting one. So like the large integer 3, if you go back and look at the test fixture, has the values 3, 4, 5, 6, 7. So it should have a 7 at digit 0. So again, digit 0 is the 1's digit, or the 10 to the power 0. Digit 1 is the 6, and so on, right? So the index we're using, also you can think of that as the power of the digit in our representation here. So large integer 3 at position 0 should be a 7, and then at position 4, so this is 10 to the power 4, should be a 3, and so on, right? This should be actually easier probably than max digits, because all you have to do is access the correct index. Oh, there is a little bit of an error checking in here. So if you access a digit at position like a -1, so this would represent a fractional power, 10 to the -1, but we're not representing a floating point or fractional powers with our large integer. It's an actual integer whole number type. So anything less than 0 should return 0, or anything above the number of digits, right? So if it's a digit that you have, you should look it up in the digits array and return that value. But if it's bigger than the number of digits that you have, you should just return 0. Or if it's less than 0, you should return 0, right? And again, that should make sense because if I have a large integer 3 with the digits 3, 4, 5, 6, 7, if I ask for digit at 5, I mean, there's 0 of the 100,000 digits, right? So anything above the actual number of digits I've got in my large integer should just be a 0. All right. And yeah, I need to wrap up here. So our ultimate thing is that we want to actually, our large integer class, we would like to support doing like all of the arithmetic. So, adding large integers together, subtracting them, multiplying, dividing them, raising to a power, right? So I don't have you do all of those, but we lead up, all these methods are going to be used in order to implement the first of the basic sort of arithmetic operations between large integers. So the ability to add them together, right? So one thing that'll be useful in the algorithm to add digits together is an append digit. So the large integer 2 simply had a digit of 5 in it. So if we append a 7, we're going to be adding a new digit to be the new most significant digit of the array. Okay, so append might not be a very good name. That kind of implies that it ought to go at the end, like the least significant. Although remember that again, the array, the least significant digit is actually at the first index 0. So append digit is actually appending it, is actually adding it to become the new highest, most significant digit for the append digit. Okay, but the other thing to keep in mind here is that so this isn't as simple as it sounds, because you're going to have to dynamically allocate an array, a new array of digits to do this. So a digit array for Li2 only has an array of size 1, so enough memory to hold 1 digit. So if I want to append a new digit, I need to allocate a new array of digits of size 2. I need to copy all the values from the original digit to the newly allocated array of digits, right? And then I need to add the 7 to the most significant digit, and then you need to update the number of digits. Okay, so this one takes a little bit of work because you have to do a memory allocation and you have to copy all the values from the old block of memory into the new block of memory to correctly do the append digit. Right? And then finally for add, I'll talk more about add on Thursday, but you're going to be reusing many of those functions, member functions that might not make sense why you need like an append digit or the max digits. But they make the implementation of add relatively simple if you reuse them and do the algorithm as is suggested and required here in the description of the add function. All right. All right. Yeah, so I'm going to wrap this up, and because I need to run here. I'll post this video, as usual, feel free to join if you can, if you have questions, but if you can't join, or at any time, just send me an email if you have questions, send me your code if you want me to look at something, have a problem with something. And I'm happy to also set up Zoom meetings if people need those, or even face-to-face. So, all right. So like I said, that again, I need to run, but I'll end the video here and I'll see you guys later then.